In video 7, we're going to show how to alter the area boundary, which is often computed from a less than perfectly accurate DTM. Maybe it came from Google Maps itself. Maybe you know the site better and need to revise the boundary by hand. In this case, we know for a fact the land breaks off at the crown of the road here at the north portion of this watershed. So let's go into P3D and calculate right now on the fly the watershed boundary. What we're going to do is, as you can see, we've gone with 100 foot of sheet flow. Just below here we had quite a bit of shallow concentrated flow, actually 435 feet to get the water to the channel at the edge of the road. And then we divided the channel portion into 6 segments. We're doing the TR55 method for the time of concentration. You can see that here. And it comes up with a grand total of 36.519 CFS. And you can see that right here. So this is matching the natural result from the DTM computed watershed, but now we want to adjust it based on our knowledge of the site. Let's bring in Google Maps to assist us in this. We're going to download Google Maps and turn on, attach it to the surface in the area of the tin. Highly recommend doing that. And just like that, the Google Maps are downloaded, and you can see clearly that if this is the breakoff point of the watershed and none of the water on the north side of this road flows into our target area, we need to reduce the overall boundary by this amount. That's done by the divide a subbasin icon at the top of the screen, and you just do it on the fly. You pick, it has a little snap going, pick, it's already accomplished that division. Let's do some more. We'll go from here, and that should be sufficient for our exercise. And we've reduced the area. And then you simply go and recalculate the storm. While we're doing that, we'll launch it here and make a few points. This road is actually called Skyline Drive. It runs right along the skyline, really, the crest of the terrain. And so the DTM that was internal to the tin was very accurate here. Not accurate over there where we revised it, but surprisingly accurate around the curve of this Skyline Drive. Now we look and see that our peak flow is 36.27, and it is less, not because our rain intensity changed, the longest flow line is still the same, not because our coefficient C changed, it's 0.411. It barely changed. It got a little higher because, proportionally speaking, the low contribution of this area was stripped out, and it favored slightly higher C coefficient, went up by 1 thousandths from 0.410 to 0.411 in the upper right there, but the area changed. So the overall peak flow was reduced by 1%.